So we'll start this video taking a look at an example of polynomial functions. And so in these problems we're going to be basically asking you to identify whether you're dealing with a polynomial function, put it in standard form, and then identify a number of the parts. And so you can look at example number 1 and you can see that we have a series of exponents. They all seem to be whole numbers, and if you remember, 7 is a constant value, so that's understood to be x to the 0. So that tells us that we are dealing with a polynomial function. However, to write it in standard form, it must go from the highest degree value or highest exponent value down to the lowest exponent value. So we need to rearrange these. Now keep in mind that the coefficient and of course the sign with the coefficient kind of all go together. So we can see that that is one term, this is another term, and of course this is another term. And so when we move these around, we need to make sure that the signs and the coefficient values move with it. And so you can see here in the solution, f of x equals -3 x to the 4th plus 1/2 x squared minus 7. And so we have a degree of 4. Now notice that we technically have a value missing here. We have a 0 x to the 3rd, if you will, plus 1/2 x squared minus 7. And so you can see here that the x to the 3rd term is missing. It's understood to have a 0 coefficient. However, in this particular case, to write it in standard form, it's not necessary to write the x to the 3rd term if it's being represented with a 0. So it will be left as a blank exponent there. So the degree is still 4, even though you don't see 4 exponents, but the highest exponent value is a 4. And so since it's a 4th degree polynomial, that function type is called a quartic, and then the coefficient that is going with the degree variable is -3, so that is the leading coefficient. So before you can identify any of these parts right here, you must put it in standard form. So let's take a look at some examples. If you haven't had a chance to work sample problem 1 yet, parts A, B, and C, go ahead and take a second to do that and then come back and see the solutions. Okay, so let's take a look at this first one. It says decide whether it's a polynomial function. So in order for us to make this determination, the first thing we need to do is determine if the exponents are whole numbers. And so if we look at this, we can see we have x to the 3rd and then we have 3 to the x power. That variable right there in the exponent is not a whole number, so this is not a polynomial function. So we can just go ahead and stop at that point. There's no need trying to rewrite anything. As well with part B, we have an exponent that is a negative. Now the negative is an integer, but is not a whole number. And so again, that is not a polynomial function. Lastly, we have C, and this is one that usually tricks people up because they see the pi and they see the radical and they see the various strange symbols, and they think to themselves that it wouldn't be a polynomial function. But if you really look at this, everything has exponent that is a whole number. So we have x to the 1st, x to the 2nd, and x to the 0. Now of course x to the 1st and x to the 0 aren't necessarily written like that, but they're understood to be there. So that makes this a polynomial function that we need to write in standard form. So now I need to rearrange this with the highest exponent first. Now keep in mind the coefficient, whether it's a symbol like pi or a radical value, has to go with that. So we're going to say pi x squared minus 0.5x minus the square root of 2. We can see that our degree is 2. Our leading coefficient is pi. And if our degree is 2, then we are dealing with a quadratic equation. It's not a quadratic equation that you're probably accustomed to seeing, but nonetheless it is still representing a quadratic. Alright, well that's some good examples on identifying polynomials.